In this video, going to show something like finding inverse with the restricted domain. So why we need to do restricted domain when the original function is not one-to-one function, we have to restrict it. So for example, by looking at the two diagrams that showing here, so the left-hand side is a cubic function. So originally, it is one-to-one function, so we no need to restrict the domain. But when it's a quadratic function, as we know that quadratic function is open downward or open upward. So when we're doing the horizontal line test, it will cut more than 1 point. Therefore, we have to do restriction based on the turning point. So in this case, the turning point is equals to 0, 0. Right? This is a 0, 0. Therefore, the restricted domain will be two-sided. It is either left-hand side of the 0 or right-hand side of the 0. So now we will be looking at the example 12, which is come from our lecture notes, page 103. So now you are given the two functions. Because only these two functions we need to do restricted domain. As we know that linear, cubic, rational, logarithm, and exponential, this five function is past the horizontal line test. So now we are showing you absolute and quadratic that is not one-to-one function from the nature of the domain. Okay, so now we look at the question. So we enlarge it, we look at the question. The question is given that graph each function and use the graph to determine whether the function is one-to-one or not. So obviously we have to use a horizontal line test. We cannot using algebraic approach. So if the function is not one-to-one, can you see that is the second instruction? We have to restrict the domain and find the inverse. Last part, we have to graph the function and also the inverse on the same coordinate system. Okay, so now we're looking at the first, the question A. So the question A from here, as we know that if we want to sketch a graph, I told you before, so it will be coordinate 2, 0. So the vertex, it will be x equals to 2, y equals to 0. So the x-axis will be here. The y-axis is around here. Okay, so this is a 2. So from here, we will draw any random horizontal line and we label its y equals to k in general form. So you double check how many intersection points here. There are 2, isn't it? Then you will write it as by using horizontal line test. Please in full sentence, horizontal line test. Y equals to k intercept function fx at 2 points. Therefore, it is not one-to-one. Okay, so this is the explanation by using graphical approach. So, and then second instruction, if it's not one-to-one, we need to restrict the domain. So, how to restrict the domain? The restricted domain will base on the coordinate of the vertex. So now we're looking back here. So the coordinate here, the x value is 2. So this means the restricted domain it will be negative infinity until 2, or we can choose 2 to infinity. So in this video, I'm going to show you both. Okay, so when we're using the first domain and the second domain, it will come up with the different graph. Okay, for absolute function, so as we know that based on the definition, the different interval will give you a different function. For example, when the x is greater than 2, we will taking the function modulo x minus 2 as x minus 2. But if you are given less than 2, okay, less than 2, and the function that you will chosen, it will be negative in bracket x minus 2. So now we look at the question. So since the question you are given, okay, let's say I'm taking this as a first set. Okay, first set of the domain. So I'm taking 4, 2 to infinity. So it means that our function fx, we will choosing x minus 2. So when we finding inverse function from the composite function method, we will using x minus 2 as a function. So automatically it will become f inverse minus 2 equals to x. F inverse equals to x plus 2. Okay, so we're already getting the function. So you will find that it's very simple. It's not that difficult. Okay, but we just need to restrict the domain, then you will given you domain of f. You follow back, okay, 2 to infinity, and the range we were taking the y value as a 0 to infinity. Okay, because you look at the diagrams here, when you greater than 2, the minimum point of the y value is still 0. Okay, so, and do not forget, there is a relation between the function domain of the function is the range of the inverse, and this one is the other way. Okay, so we're already getting this. So now what we need to do is we have to sketch a graph. Okay, so how to sketch a graph? Firstly, we must referring the domain and range. Okay, first we sketch the x-axis and y-axis. And for sure, do not forget about the y equals to x as the axis of symmetry. So we're reading this. This is a x value for f, and this is a y values for the function. So it will be 2, 0. So it will be here, 2, 0. So the function is linear function, so going up. Okay. Secondly, this one is a y value for the inverse, and this is an x value of the inverse. So we're reading 0, 2. So x0, y equals to 2. It will be here. So, and the function also positive x plus 2. So the graph is still going up. So you will find that these two graphs, they must symmetrical with respect to y equals to x. So this is how we sketched both graphs on the same coordinate. Okay, untuk second case. So the second case, it will be the domain is from negative infinity until 2. So from the definition of absolute function, okay, we look back here. So we were choosing s less than 2, then the function is negative x minus 2. So we will rewrite again. Therefore, the fx equals to negative x minus 2, or we can simplify it as a 2 minus x. So from here, 2 minus x, obviously, the graph will be going down, eh? Okay, so finding the inverse, f of f inverse equals to x. So 2 minus f inverse equals to x. So we rearrange it f inverse as a subject. We get that is 2 minus x is exactly the same. But do not forget, the domain and range might be different. Okay, so once you get the inverse, so again, the domain, because we already restricted negative infinity until 2, and the range, it will be, so as we know that from the graph, right, 2 minus x. Okay, look back again the diagram. So this part, okay, this part is the yellow one, and the other part is the greater than 2. Okay, so now from here, the range obviously is still from 0 to infinity. It is not below the x-axis. So, and this is the range of inverse, and this is the domain of inverse. Okay, so let us proceed to how to sketch a graph. Firstly, we have to put the x-axis and y-axis together with the y equals to x. Okay, so the function is 2 minus x, follow the negative 2. So it means this one is the x value and this is a y value. So we're taking 2, 0. So x equals to 2, y equals to 0. So it will be here. Okay, this is a 0. So how's the graph looks like? So the graph will be going up. That is where the intercept is 2. Okay, so this is the function fx. Okay, for the inverse, this one will be the y. This will be the x. So x equals to 0, y equals to 2. 0, 2, it will be here. Okay, overlapping the existing function fx. And what is the function? The same function, isn't it? So, but it will be going down. So this is the f inverse, which is partially overlapping with fx. And this one is the fx. So this is how we recall back. From the given question, okay, we already proved that it is not one-to-one function, and the restricted domain with two options. Option 1, we're choosing greater than 2, And the procedure is determine the function based on the interval, which is x minus 2. So getting the inverse, getting the domain and range, lastly, we sketch a graph. So they must look symmetrical with respect to y equals to x. And the second choice, the function is 2 minus x. So procedure finding inverse also the same. But during the graph sketching, we found that the two graphs are overlapping because these two functions are the same. The different thing is their domain and range is not and on the same track. So this is how we get the example for A.